In this question, we're looking at probability. It says there are 3 counters in this bag. We've got a red one, a green one, and a blue one. And Mike, first of all, comes and takes the counter from the bag. He then puts the counter back in the bag. That's quite important for this question. And then Ellie takes the counter from the bag afterwards. The question we're given is Ellie more likely to take a blue counter than Mike is from the bag? And we need to explain our answer. So, first of all, Mike goes up to this bag, and there's 1 blue counter and 3 counters altogether. So the probability that Mike takes one is 1 out of 3. Mike then puts the counter back into the bag. No matter what counter he chose, he's still going to have a red, green, and a blue counter in the bag. So Ellie is in exactly the same situation because there are still 3 counters and 1 blue one. So it's 1 out of 3 for Ellie as well. So the answer to this is no. And the reason is the probability is 1/3 for both of them. Okay, the next part of the question. List all possible combinations, and this is an important word, of the 2 counters that Mike and Ellie can take. So, first of all, Mike goes in, takes a counter, then Ellie goes and takes a counter, and we need to list all of the possibilities that could possibly happen. The easiest way to do this is, first of all, just give Mike a counter. Let's say, first of all, Mike takes red. Now, Ellie has 3 options. She could take red as well, green, or blue. So, let's say she takes red as well. And then we stick with Mike, red, until we've run out of possibilities for Ellie. So, we've already had red, red. So now let's do red and green. And let's keep Mike with red. And this time we've had red, red, we've had red, green, let's have red, blue. Now we've run out of options where Mike has red, because we've had red, 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 green, and red, blue. That's all of the options where Mike has a red counter out the front. So let's switch now and look at where Mike could have a different counter. Let's give him blue. And do exactly the same thing. So Mike has blue this time. What could Ellie have? Well, she could have a red, a green, or a blue. So let's do Ellie with red first. Let's keep Mike fixed with blue, and then we'd have blue green, and then we would have keep Mike fixed with blue again, but we've had blue red, we've had blue green, the only one missing is blue blue. And then the final set, so we've had Mike with red, and then all the possibilities, we've had Mike with blue, and all the possibilities. Finally, let's have Mike with green, and all the possibilities. So we've got green red, we've got green green, and finally green followed with blue. So there are 9 possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9. The final bit of this question then says find the probability that Mike takes a blue and Ellie takes a green. So if we go back to our list here, we can see Mike takes a blue and Ellie takes a green. So we're talking about this one here, where Mike is blue and Ellie is green. There's no other one that is blue and green, because we've already done that one. And there are 9 combinations altogether, in which case the probability must be 1 out of 9.